Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, it's time for the second round of modifications to our little 6P1. And when I first did this, all I had was an oscilloscope, and I honestly didn't have a real grasp on how tubes interact with each other. And I'll be honest, last week when I was working on this, I was going, what is going on with this thing? And then kind of came back to me. It's like, oh yeah, now I remember that. And now I think I get what's going on with this. And it gets back to my mantra with single-ended amplifiers. We need to run the output tubes within an inch of their life. Every amplifier I've seen that kind of softball runs the tubes at half their dissipation, there's problems. We saw it with the A50. We saw it big time with the A12. Just swapping in some tubes that were run close to their max without changing anything else cut the distortion in half. And I think that's part of what we've got going on here. But we do have a mod here, and I initially called this the advanced mods. But really, guys, it's changing two resistors and moving the end of one resistor from one place to another. This is not a rocket science or difficult modification to do. And as you will see, it does produce nice results even if we don't get any more power out of this amp. So let's jump into doing this mod, showing you the results that we get from it, and then we'll close this thing up with some final words about these first two steps of modifying this cheap little China tube amp. Okay, so it's time to jump inside this amplifier and do this modification. And I know this is intimidating to a lot of people, but this is really not a hard job to do, and it's a lot simpler than the job that we had to do on either the 300B or the A12 EL34 amp that we did earlier in the channel. And again, I'm going to go step by step and show you how I did all this. One optional thing, I used this thin PTFE tubing. I believe it's sold for use with 3D printing, and it fits just over the leads, the resistors, and just makes a cleaner install. But this is totally optional. You could also use some just small diameter heat shrink tubing, or honestly, you don't need to put anything on them. But I just think it makes a nicer looking job. So first thing we're going to do is we're going to get a nice hot iron with a clean tip. And we're going to unsolder this one film cap. And I'm going to go ahead and bend it up like that and get it totally out of the way so we can see what we're doing here. This pin here is where we're going to be attaching everything. So the first thing we want to do is come in here and cut this resistor lead as close to this pin as we can. So this resistor right here, let me see if I can move this red wire out of the way a little bit so you can see it better. This resistor right here, we're cutting this pin as close to this tube lug as we can. And then we're going to pull this resistor up like that, and we're going to move this resistor from this pin to this ground right here. And so we're going to come in and heat this up. And solder the other end of this 1 meg resistor to this ground. So we're going from the grid of the upper triode to the ground with this 1 meg resistor. Now the other thing we're going to be doing is we're going to be creating a voltage divider across this resistor and I'm going to be using a pair of 1 meg resistors. You can either use a single 2 meg resistor, or like I'm going to be using two 1 meg resistors, because we've got to bridge across this part of the amp over to this terminal right here. And I'm going to go around through here and around this capacitor to connect to this point right here. So I'm going to get a little piece of this PTFE tubing, put it in this resistor so it looks like that. And we're going to be going from this pin up, over, and across to the other side of this capacitor. So I'm going to go ahead and cut another piece of that PTFE tubing and put it on the other lead of the resistor. If you were going to be updating the coupling caps, now would be the time to do that too, because you're going to already have this one almost removed. But I'm going to do this mod just putting in the two resistors so you can see how much difference the two resistors make in how this amplifier sounds. And it's amazing that two resistors could make that much difference in the way this amplifier performs. So I went ahead and put a little hook on the end of this resistor like this. I'm going to come in here and, let's see, I may go under this little yellow wire here. And, wow, this is not cooperating. Put that just like that, and come in with the solder. And solder that to the end of that capacitor. Just like that. And now we're ready to connect this back over to here. Stick it into this connector a little easier. Just like that. So this film capacitor is now going across this resistor to ground. And now we need to have this resistor come around like that. So I'm going to go ahead, trim that off, cut a little piece of tubing. And again, this tubing just makes this look a lot nicer. It's definitely not mandatory. And then again, I put a little hook like that on the end of this wire. Hook the two resistors together, and then come in here and solder that joint together. And then this is gonna get that down low. And this is gonna come around here and solder to this joint right here. So let's cut off another little piece of this tubing. Lay that in place just like that. And actually, before I do that, I'm going to get a little piece of heat shrink tubing. And cover up this little joint right there that I created. So let's go ahead and Shrink that down. I know a lot of people use like a little heat gun or something to shrink up their heat shrink tubing. I just use the side of the soldering iron and solder this into the resistor in place. And there we go. We can bend that around and make it look a little neater. But that's it. And now we've added 2 megs of resistance between the positive lead to the grid, and then from the grid to the negative, and we've created like a 2-to-1 voltage divider here to set the screen voltage of the virtual pentode. And we're going to show you here in a minute what that did for this little amplifier. Okay, so we have one channel that is unmodified and the other one that we have modified with our fixed screen voltage on the virtual pentode, which is basically we're putting a fixed voltage using a voltage divider on the grid of the upper triode in the cascode. And on the original one, it was using a form of auto bias called grid leak bias that changes the voltage on that screen based on the waveforms that are coming through the amplifier. And it's really not an ideal way of doing this. It's used a lot in guitar amps, like I said, and I think that's where a lot of our distortion is coming from. The other thing about this amplifier is this is a massively overkill driver setup for these output tubes. If you remember, the cathode voltage on this pair of output tubes paralleled was 14.5 volts. So we only need 30 volts peak to peak to drive these output tubes, and they don't have a lot of capacitance, so they're not a very hard tube to drive either. And I experimented with my own personal 6P1, which I kind of used for a guinea pig, and I was able to easily drive the amp to clipping using 1/2 of a 6SN7 as a simple triode driver. So this dual section cascode was totally unnecessary. If you remember, I used this setup to create over 140 volts peak to peak to drive a 300B tube. So what we're going to see here with this fairly strong signal coming in, we got 3 volts peak to peak sine wave, and this is our signal coming in, this is our signal going out, and this is hooked to the grid of the output tube on the unmodified channel. So as we turn up the voltage, we see right at, there's 30 volts peak to peak, which is all we need, and there it's trying to push the grid of the output tube positive, and it's not having any part of that. And so there's our 30 volts peak to peak that we need to drive the amp to full power. But if you notice, see how hard-edged that clipping is? Let's look at the other channel. Okay, this is on the grid of the output tube of the other channel. The edge is a little more rounded off, and the top of this is a little more rounded. And I know that's real subtle looking. And when I first worked on this amp, I didn't have an analog Discovery 2. So I was having to use very subtle looking clues on the oscilloscope to try to decide if stuff was going to be better. And then I had to just plug it in and listen to it. And the amp clearly sounded much better with the driver modified using this fixed bias on the upper section of the cascode. And just for you new folks to scopes, over here I have 10 volts per division, and it's set on the 10x probe, and I'm using the 10x probe setting on my probe that I'm got hooked up to the grid of the output tube. Now I'm hooking it to the grid of the output tube because that doesn't have the plate voltage that you would see on the plate of the driver tube. And while it's only 200 volts and this scope will work with up to 400 volts, there's no point in putting a couple of hundred volts of DC into your scope if you don't need to. So it's much safer to take these readings on the grid of the output tube that's on the other side of the coupling cap that blocks the DC. So now we're going to put the probe back on 1x, and we're going to go back to our 5 volts per division and turn the volume up. And there's our clipping again. And there's our 9 volts peak to peak like we were seeing. So now let's go to the modified channel and see if we see anything different on the output after we've modified it. And I'm not expecting to see a whole lot. So this isn't earth-shattering to the power of the amplifier, what we did to the grid of the upper section of the triode. But I still think that we're going to see an improvement when we put it on the audio analyzer suite. To get more power out of this amp, we're going to have to do something to the output tubes, because the driver is not what's holding this back. I checked this driver with the output tubes unplugged, and it'll easily do 50, 60 volts peak to peak. So it's not where our problem is. It's not where the clipping's happening. The clipping's happening from the output tube being biased as soft as it is. And again, the problem is going to be if we try to bias them harder and turn up the milliamps going through these tubes, then we're going to run into the issue of overheating the output transformer. And I've got some ideas on that we'll probably go into in our next video, but I want to put this thing on the Analog Discovery 2 with the audio analyzer suite and show you the difference in these two channels just adding these two resistors to the driver tube does. Okay, so now we've got this little amp hooked up to the Analog Discovery 2 with the audio analyzer suite. And when I first did the videos on this little amp, I did not have this piece of test equipment. And while I knew that it sounded better after I did the mods to the driver, and multiple people have done this mod and have said that they agree that it sounds better, I didn't have any real way to quantify it, because like you saw on the oscilloscope, there wasn't anything super obvious about the difference in the two, but I knew it sounded better. So I've got it hooked up with both channels, and it does struggle a little bit with measuring two channels of an amp that aren't identical. When there's some difference between the two channels, sometimes one starts up the scale before the other one, and then it ends before the other one ends. And we may have to check these one at a time, but these should be fairly close. So let's see how this turns out here. And here we go. And look at that. The red is the unmodified channel and the blue is the modified channel. And they both have this same dip right here. So at 1 watt, the modified channel has 1.5% distortion, and the unmodified channel is at 4%. And you can see here at 2 watts, they're getting closer. They're at 3.5 for the modified channel and 5.5 for the unmodified one. But this right here, this is all in the output tubes. I mean, up to this point, from here to here, we're seeing the distortion from mostly the driver tube and maybe a little bit from the output transformer. But at this point, we're not into any kind of clipping or trying to push the output tube grid positive, and so that's why it looks so linear. And I think right here is where it's starting to try to push the output tube grid positive, and it flattens here and then it just takes off. So like at this point right here, there's over 2.5% distortion difference, changing how the upper section of the driver triode is powered using a voltage divider instead of depending on that grid leak bias. So clearly we're moving in the right direction, and for a couple of resistors and not going any deeper into this amp, I think this is a huge win. Well, as you can see, this modification to how the driver tube is biased, or the upper section of the cascode is biased, more than cut the distortion in half. And while we didn't get any more power out of the amp, we did clean up the distortion, and now we're ready to try to get some more power out of it. This is where I left off the first time when I worked on this little amp, but I'm not done with it yet. I want to try connecting these output tubes in pentode mode. I also want to play around with taking 2 of the tubes out and bias 1 of each of these and see what that does. We might get more power running 2 of these tubes in pentode mode than we did running 4 of them in triode mode, and taking some load off this power transformer so we can actually do it. And if we do, we'll just put a couple plugs in those holes and call it good. There's a lot of things I want to try. But again, what really made me just give up on this, and was really what made me build that 6SQ7 EL34 amp, was that this chassis is not big enough to put iron big enough to put out the power that this amplifier claims it can. These are advertised as 5 watt output transformers on eBay. This power transformer, I'm guessing, is probably struggling to put out 100 milliwatts of power, and 4 of these tubes running full tilt is going to be 160 milliwatts, plus 10 or 15 milliwatts for this. So you probably want 175, 180 milliwatt power transformer to be able to actually power this amp to its full potential. And that's probably part of the reason that they did it like this. The other thing that I'm convinced that these China amps are designed for appearance. Most of the design decisions are made based on that. This amp easily could have had one of these 6S and 7s in the center here, used a solid state rectifier, and probably used a couple of these tubes and got the same power. But instead, it's got, look at all these tubes we got in this thing. Got all this stuff glowing. Ooh, we got these big tubes on the side. And there was no reason to put a cast-coated 6S and 7 in here to get 30 volts of swing. Just a total waste. And they didn't put the money where it should have, but again, they probably got these tubes for 50 cents a piece you know, in the China market somewhere. So anyway, we're going to do what we can for this. I do feel like that we're kind of up against a brick wall. This will never be a great amplifier. But if you only need a watt or two, what we've done in this episode and the previous one will get you there with low distortion and a pretty good sounding amp if you put these Soviet output tubes, and honestly these 6H8C driver tubes are pretty decent. You're going to be hard pressed. You're going to be spending a lot of money getting some black plate Sylvania somethings that are going to sound better than these. So focus on getting you some Soviet tubes, do these mods, and maybe enjoy this thing for what it is. And if you need more power than this, you really need to get some other kind of amplifier. So anyway, probably going to be one more episode. It may be a few weeks to where I get back to this because I want to start working on that 47 amp. So I hope you've enjoyed this reboot of this series. And if you have, please subscribe to the channel. Please like the video. And we'll see you at some point in the future for more 6P1 fun. Have a great day.